All right, everybody, hello and welcome back. Today we're going to do is we're going to work on what we call log properties. All right, so essentially the purpose of this is for us to set the stage for when we start to solve exponentials and particularly logs. What we need to do is learn about these log properties so we can condense certain equations in order to isolate our variables. So again, we're kind of setting the table as something that's going to happen over the next couple days. But we got to work on these properties first. So the properties of logs are, first we have the product property. Now, essentially what it means is when you have two logs that have the same base and you are adding them together, you can condense the two logs to one log if you multiply their arguments. So we have log base b of a plus log base b of c equals log base b of a times c. So again, that is the product property. Next, we have the quotient property. So if I have log base b of a minus log base b of c equals log base b of a divided by c. So if I've got two logs with the same base and I am subtracting them, I can condense from two logs to one log if I divide their arguments. Finally, we have the power property. It says if we have a times log base b of c, then that can be condensed to log base b of c to the a power. So that value in front is essentially the exponent of our argument. Now, there's a couple different reasons for these. Mathematically, we could look at numerical values that would help us kind of see if this is the case. For now, what I want you to do is you're kind of going to trust me a little bit and know that these properties are in fact true. So we've got the product property, the quotient property, and the power property. What we are going to do today and really tomorrow is we are going to work on expanding these out. So going from this direction to this direction, and then condensing, going from this direction to this direction. Now, to be completely honest, more often than not, we condense more than expand in order to solve. However, it is important that you understand that our properties go both ways, so we can expand and condense. So let's take a look at a few examples. We have log base 5 of x to the 6th times y to the 5th. Now, hopefully we recognize there's a couple different things going on here. First of all, we have exponents. That means we are going to use our power property. But then we also have multiplication going on in there, so we are also going to use our product property. Now, what typically happens is students take a little bit to figure out which one of these we need to do first. Now, if we think about what we would do if we used power property first, we'd have to take our exponent and put it in front. Well, if I take the 5, for example, and put it in front of my log, that implies that 5 is also the exponent of x, which it is not. X and y each have their own exponent. So I'm going to have to separate those first using my product property before I can do the power property. So this is going to expand back out to two logs. Log base 5 of x to the 6th, and then we have log base 5 of y to the 5th. Now, because these things inside our argument, we are multiplying those two values, we are going to have a plus in between. Again, that is our product property. Next, what I want to do is I'm going to use my power property. I'm going to take my exponents and put them in front of my logs. 6 times log base 5 of x plus 5 times log base 5 of y. Now, typically what we should do is to make sure we're done, take a look at these arguments, and there's not really anything on the inside there that can be simplified any further. There are no more properties for us to use. This is the fully expanded version of our original expression. All right, so it's essentially what these problems are going to look like. We've got some more examples we can do. Now we have the natural log of x divided by y to the 6th, all raised to the 4th power. So hopefully we see that we do have the power property once again, and now we have the quotient property because we have division. So we need to decide which one we're going to do first. We might actually end up doing this multiple times, but we have the power and the quotient property. Now, because this 4 is the exponent of everything on the inside, that means that we need to use our power property first. So we get 4 times the natural log of x divided by y to the 6th. All right, now what I can do is now I can do my quotient property and separate what is inside as my argument. So we still have that 4 out in front, but realize the 4 belongs to each part, so that means it's going to be a part of our log with an x and our natural log with a y to the 6th. Because we are dividing, we're going to have subtraction between. And we're just about done. However, if we take a look at this argument, there's nothing to simplify. If we take a look over here, we should be able to see that, again, we have something in our exponent, so we can move it to the front. Now, because we're moving it to the front, we are technically going to have our original log, 4 times the natural log of x, but we're going to have minus 4 times 6, or 6 times 4, of the natural log of y. So those two values in front are going to be multiplied to give us our fully expanded version of 4 times the natural log of x minus 24 times the natural log of y. So this is our fully expanded version of our original. All right, so we've used all of our properties so far when we are expanding. We've used the quotient, the product, and the power property. Sometimes you're going to have a combination of 2, a combination of 3. As you can see here, we actually use the power property 2 separate times. So it kind of depends on each problem. Now, let's do a little bit of condensing. Now, in order to condense, all right, we're essentially just going to go the other way. So in this case, we're going from 2 logs to 1 log, right? We want to condense this equation, make it smaller. So these 2 logs are going to condense to 1 log. But there's actually something else I need to do first. Now, we also have some numbers in front. So I'm going to have my power property. Division means quotient property as well. So because my 30 only belongs to the A and my 6 only belongs to the B, I'm going to do that power property first. So we're going to have log base 6 of A to the 30th minus log base 6 of B to the 6th. Now that we've done that, we've got those values out in front, we have subtraction. So my subtraction tells us that we are going to be using the quotient property. So now I'm going to condense from 2 logs to 1. Log base 6 of, now I'm going to have A to the 30th divided by B to the 6th. So the value in front of my subtraction sign is my numerator. The value in the back is my denominator. Now you might notice that I put parentheses around my argument here. That's technically not necessary. However, I think it's a little bit easier to understand and see our problem. Really, I prefer to do it on all parts, but sometimes you see it, sometimes you don't, so we need to make sure we're comfortable with both. All right, so as you can see, this is our original right here. We condensed down to 1 log, and it really does look a lot more compact. Our equation is a lot smaller because it is condensed using our properties of logs. Now, the last thing I want to talk about here is this problem. So we have 4 times log base 3 of z plus log base 3 of x divided by 2. So the first thing I want to do is realize that the division of 2 on the side is really just multiplication of 1/2. Now, the reason that's important is because now I can use my power property to take those numbers in front and put them back as exponents. So this will become log base 3, I should rewrite that, 3 of z to the 4th plus log base 3 of x to the 1/2. Now, one important thing that I want to realize here is that raising something to the 1/2 power is the same thing as taking the square root. So we should actually rewrite this as log base 3 of the square root of x. All right, so we got our power property out of the way. I am now going to do my product property because we are adding 2 logs together with the same base. That means they can condense to 1 log with the same base, and we are going to multiply their arguments. And this is my fully condensed version. So we went from 4 times log base 3 of z plus log base 3 of x divided by 2 all the way to log base 3 of z to the 4th times the square root of x. So again, it's a lot of work, and we might not see the end goal right now, but the purpose of using these 3 properties is to expand and condense logs. We're going to use these properties a little bit later down the line to solve logs. And so we kind of got to practice going both ways now, just so we are comfortable and we are able to manipulate log equations when necessary. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out. Thanks.